Evaluation of spray application techniques on palm and stone fruit trees for improved spray deposition parameters for the control of late-season red spider mite. Palm and stone fruit tree structure, planting style and orchard layout have changed dramatically over the past 10 years through the process of orchard modernization. Orchard modernization entails a shift from conventional large trees with wide inter-row spacings to high-density trellis plantings with narrower canopy depths and row spacings. Conventional spray application methodology is still used in these modern orchards. These conventional application methods are based on and were developed on conventional open-vase tree structures with 3-row volumes in excess of 2,000 to 3,500 liters per hectare and orchard layouts with row spacings larger than 4.5 meters. The question arises if the application methods such as conventional spray speeds, for example 2 to 4 kilometers per hour, air volumes in excess of 48,000 cubes per hour, together with 3-row volume determined water volumes and dosing, are optimal for control, especially pests such as red spider mite and scale insects, where optimal deposition parameters are cardinal for control, and these new high-density orchards. Together with the concept of canopy-adapted spraying, this study focuses on determining optimal spray volumes for high-density orchards. Through fluorometry and digital image analysis, the influence of spray volumes ranging from 250 to 2,000 liters per hectare were evaluated in a modern 4-meter, 2,000 liter per hectare 3-row volume apple orchard using canopy-adapted spray methodology. The effects on droplet deposition and deposition parameters were evaluated as influenced by the spray volume range. Spray speed and droplet VMD size was kept constant with spray volume manipulation done through nozzle selection. As expected, droplet retention quantity increased with an increase in spray volume, higher volumes, higher amount of droplets. 3 droplet quantity retention zones were identified with 750 to 1,500 liters per hectare indicating to be optimal. Droplet variation between leaves indicated less variation at low volumes and an improvement in the middle range with a drop-off past 1,500 liters per hectare. Droplet distribution quality per target leaf indicated an increase in distribution quality on a target from 250 to 750 liters per hectare from where variation in quality stabilized. This data is based on a TRV volume of 2,000. In trial 2, pigment dosage was adjusted to spray volume in relation to tree row volume to simulate the amount of plant protection product landed on leaves. As expected, similar deposition quantity was realized throughout the volume range with no sign of runoff at higher volumes. Values, however, was very low in relation to previous deposition trials, which can possibly be ascribed to poor pickup during analysis. This will be repeated. Deposition uniformity achieved was best between 250 to 500 liters per hectare, decreasing with an increase in spray volume up to 1,750 liters per hectare for a 2,000 TRV orchard. Using canopy adapted spraying, that is, matching forward speed and air volume to orchard canopy requirement, together with tree row volume determined dosing, seems to be adequate. Data collected from trials thus far do indicate that there is a spray volume sweet spot to achieve optimal deposition that can theoretically be based off an orchard tree row volume through a future formula. Our next trials in 2020 will investigate this further through ranging spray volume trials. Red spider mite control efficacy trials will be integrated to couple deposition data to bioefficacy. Similar to as was done by ProCrop to determine optimal spray volumes for pecan nut trees based on canopy volume, a formula will be derived from collected data for palm and stone fruit orchard, specifically for red spider mite control. Myself and the ProCrop team thanks you for listening.